Hello again, Mrs. Mando here, and I want to talk to you a little more about scientific method and some different parts of the experiment beyond the independent and dependent variables. So, to have a valid experiment, we also need controlled variables. We need an experimental group and a control group. What am I talking about? Let's find out. So, first of all, your Schoology assignment is controlled variables and control group. I thought we'd start by looking at that so that you know what I'm expecting you to be able to do after this video. And here is the assignment. So it's a Google Doc. You can type right on it. And it gives you 4 experiments. Okay, so 1, 2, 3, and 4. You're going to read the experiment. So an experiment to investigate if the amount of fertilizer has an effect on the number of leaves a plant has. So I am a farmer. I want to know if I can get more leaves on my plants, and I'm going to look at a different amount of fertilizer. Okay, that's my experiment. So IV and DV, we're pros at that. Let's think of what our IV would be. So I want to know if the amount of fertilizer has an effect on the number of leaves. Let's say, what am I changing? My IV is the amount of fertilizer. If it keeps highlighting your text, don't even worry about it. I can grade it like that. My DV then would be, what am I measuring as a result of changing the amount of fertilizer? Oh yeah, the number of leaves. Okay, so number of leaves. We've done that part, right? We know how to get IV and DV. What we're adding today is controlled variables and then finding our experimental group and our control group. So I'm going to come back to this worksheet at the end and show you how it's done. But first, we need to know what is a controlled variable and what's an experimental and a control group. So let's hop over here to this little slides presentation I put together for you. And it actually has a fun little topic in it, superstitions. Woo. Okay, if you don't know what a superstition is, it's a belief or like a common misconception that people have that if you do this, something is going to happen. Like if you break a mirror, you're going to have 7 years of bad luck. If you spit on a new baseball bat, okay, that was a weak spit, but if you spit on a new baseball bat, you'll hit a home run. There's all these superstitions that people have kind of made up or passed on as a tradition through time, but superstitions are a great way to practice control and experimental groups, and I'll tell you why. But first, of course, I have a YouTube video. If you have not seen the movie Dumb and Dumber, you need to. There is a superstition about spilling salt. If you spill the salt while you're eating, you'll get bad luck. So let's watch these guys.
Uh-oh. What? What's the matter?
You spilled the salt. That's what's the matter. Spilling the salt is very bad luck. We're driving across the country. The last thing we need is bad luck. Quick, toss some salt over your right shoulder.
What the hell?
Uh-oh. Too little, too late, Harry.
There was a little word there. Let's ignore that.
Who's the dead man that hit me with the salt shaker?
Okay, so we're going to pretend that they didn't say the H word, but it's a very funny example of this idea of a superstition. So you spill the salt, you better toss some over your shoulder, not the whole salt shaker, Harry, but you better toss some salt over your shoulder so that you don't get bad luck. Is that real? We could find out with a science experiment. So let's get into this. Here are some common superstitions. So have you ever heard any of these? An apple a day keeps the doctor away. Drinking coffee will stunt a child's growth. I don't know about that. I did drink a lot of coffee, and I'm not the tallest. But if you swim right after eating, you'll get a stomach ache. If you go outside with your head wet, you'll catch a cold. That's a superstition. Breaking a mirror, like I mentioned, will cause 7 years of bad luck. Okay, this picture has some other superstitions. If you walk under a ladder, if you cross a black cat path, all of these different superstitions. And hey, it's the year 2020. we've had some pretty weird stuff go on. So maybe there's something to these superstitions, but maybe not. And as scientists, we could design an experiment to see if these superstitions are true, okay? So here's how we could test a superstition. We could do this superstition and see if we get bad luck. So be careful though, in order to prove that a superstition is really true, you have to have a group of people who do the superstition, which would be our experimental group, and then a group of people who do not do what the superstition says, and see if there's a difference between people who do the superstition and people who do not. So let's go back a slide and think about an apple a day keeps the doctor away. Is that true? Well, I could find out. I could take a group of kids and I could have half of them eat an apple a day and the other half not eat an apple a day, okay? Then over time, I could see who has to go to the doctor more, the kids that had an apple a day or the kids that did not. I would have a group that did the superstition and a group that did not, and I would compare my results. Well, guess what? In any experiment, we should have an experimental group, the group that does whatever we're trying to see, and then a control group who does not do it but lives under the same conditions. Okay, so when you go to do an experiment and it says, what is the experimental group, what is the control group? It all comes back to knowing that independent variable. So let's take an apple a day. If I want to know if the superstition an apple a day keeps the doctor away is true, my independent variable would be, you guessed it, eating an apple every day, okay? So if I eat an apple, then I will go to the doctor less because eating an apple a day keeps the doctor away, maybe. So my independent variable would be eating the apple. The group with the IV is my experimental group. So in this case, the group that eats the apples, that's who I'm experimenting on. I'm changing the IV, and that is my experimental group. Okay, what about those that don't eat an apple? Well, that's my control group. Okay, those are the ones without eating an apple a day. Now you might be asking yourself at this point, Miss Mandrich, why do we need a control group? Well, let's think about it. All of these superstitions. Let's say that I eat an apple every day and I never have to go to the doctor. But what if I'm just really healthy? What if I have other healthy habits like going for walks, taking my vitamins, drinking lots of water? Maybe that's why I don't get sick. It might not have anything to do with an apple, but the only way I can prove that it actually is the apple a day that makes me not have to go to the doctor is if I have two groups, a group that has the apple and then a group that does not have the apple. The important thing about the control group is every other condition of the lab has to be the same, okay? So with my apple a day, my control group should be the same age as my experimental group. They should have about the same type of health, like they should be maybe the same height and weight and do the same daily activities, and they should live in the same environment, okay? So my control group should have all the other factors that the experimental group is exposed to, except the one thing that I want to change. So if I want to prove an apple a day keeps the doctor away, my control group has to have the same environment, same conditions, same everything, but they just don't eat the apple a day. And then we see, these two groups live in the same conditions. One had apples every day and they're super healthy. One, they didn't eat their apples and they go to the doctor every week. Then maybe, just maybe, I could say that an apple a day keeps the doctor away, okay? So let's talk about something that I mentioned, which is, controlled variables. We'll do that in a second. But for your worksheet, I wanted to give you a huge hint. Okay, once you've identified your independent variable, your IV, then you can always know your control group because the control group is the group without the IV. or the group with no ivy. So if you're trying to do that worksheet and you're like, what's control group again? Just start writing. It's the group without this, okay? The group without fertilizer, or the group that did not eat apples. It's the group where they don't do whatever your independent variable is, okay? So that's control group. The experimental group obviously is the one that does change the IV. Okay, controlled variables. That's the other piece to this puzzle. So if I want to know if a superstition is real, remember all of the other conditions have to be the same. This is the way that you know that it didn't just happen by chance. You know that it wasn't some other factor that changed the outcome. You know that it was whatever variable that you changed, right? All right, let me get back in my presentation. There we go. Okay, so this is where controlled variables come in. Controlled variables are the things in the lab that must stay the same for every trial to ensure that they don't change the outcome of the experiment. Okay, you have to control these factors, so that's why they are controlled variables. Okay, for example, these would be things that have to be the same. So when you get to the worksheet and it asks for 3 controlled variables, think about factors that might change the outcome of your experiment, and then write the word same in front of them. Okay, so for example, you're going to start your CVs, your controlled variables, with the word same, like I want to have the same color of light, the same room temperature, the same type of balloon. Okay, so not to continue talking about the same thing over and over, but the apple a day. Would it matter if the experimental group or whoever, if they ate different kinds of apples, if they went to different places? So hello, quarantine, we know that you can't go a bunch of places and expect not to get sick, right? So they need to be in the same environment. They need to eat the same kind of apple. They need to be the same age and the same, height, weight, etc., so that we know all the other factors are the same and that the only thing changing is our independent variable. Controlled variables help you make sure that your experiment is accurate because you kept everything else the same and you only changed the IV. So let's try this, okay? I'm going to go back to my superstition slide really quick, and we're going to pick a superstition. Okay, you might choose your own. I am going to choose drinking coffee will stunt a child's growth. Okay, drinking coffee will stunt a child's growth, and the reason I'm picking this one is I'm 5'3" as an adult, and many of my 8th graders are taller than me. And my husband, he's 6'3", and that man, he drank coffee from like age 4, and somehow he's still super tall. So, does coffee stunt a child's growth? Let's go back here. Okay, my experiment. What is the effect of drinking coffee on stunting a child's growth? My independent variable would be drinking coffee. My dependent variable would be the height of the child. My problem, my statement of problem is, what is the effect of drinking coffee on stunting your growth, okay, or child's height? My hypothesis would be, if I drink a lot of coffee, then my height will be shorter because drinking coffee changes the chemical balance of my brain. Okay, that's my experiment. I'm going to try it. 3 controlled variables. This is very important. If I want to know if drinking coffee really has an effect, then other factors have to be the same. So I have to have, you know what, in this case, I'd have to have identical twins. And you know why? Because what if that person was just going to be naturally short, like Miss Mandridge, or naturally tall, like Mr. Mandridge? Okay, so they'd have to have the same genetic makeup. There's some science for you. Maybe they'd have to drink the same kind of coffee, and they'd have to grow up in the same environment, because maybe people are just taller in certain environments. Who knows? We're going to find out if coffee has an effect, because we're going to keep those things the same. Lastly, I need an experimental group and a control group. So if I'm talking about drinking coffee stunting growth, I need a group that drinks coffee and a group that does not drink coffee. Everything else the same, all controlled variables equal and same. The only thing I'm changing between the experimental group is the group with coffee and the control group, the group without coffee. Okay? Once I have those factors in place, I can design an experiment that will actually be valid and true because I'm only changing the IV and I am having a control group to compare it to. So let me go back. Let me just remind us. Experimental group is the group with the IV. Control group is the group without the IV. And then those wonderful controlled variables are the things that have to stay the same through every trial of the lab. So really quickly, let me get out of my presentation. Let me go back to your worksheet. Okay, here's the worksheet that we're doing today. And, the lights went out in my room. Oh well, okay. We already looked at number 1 together. Remember, an experiment to investigate if the amount of fertilizer has an effect on the number of leaves a plant has. So remember, to be a valid experiment, I have to have controlled variables, an experimental group, and a control group. We said that the IV was the amount of fertilizer and the DV was the number of leaves. So what do controlled variables always have to start with? Same. They have to start with same. So I want the same brand of fertilizer. Okay, if I use different fertilizers, how do I know that it's the amount of fertilizer? So I have to have the same brand of fertilizer. Okay, would the type of plant matter? Heck yes, it would. Some plants have no leaves at all, and other plants make a ton of leaves whether you give them fertilizer or not. So, the same type of plants. And what are some things that we know are going to change the outcome of our experiment if we don't do them? Well, all plants, they need the same water, same light, okay? So same amount of water for the plants. By keeping those the same, I can tell if the amount of fertilizer is going to affect the number of leaves. Okay, lastly, I need an experimental group and a control group. The secret to this is just look back at your independent variable and add the words with or without. So my experimental group is going to be the group with different amounts of fertilizer. And my control group is going to be either a group with no fertilizer, or some of you little smart children are saying, couldn't it be a group where I don't change the amount of fertilizer? And the answer is yes, you are right. There is another control group that we could have here. You only have to put one, you don't have to put both. But another acceptable answer would be the group with the same amount of fertilizer for all trials. Okay, meaning that, yeah, I still gave them fertilizer, I just didn't change the amount of fertilizer. That would also work as a control group. So I want you to try numbers 2, 3, and 4. If you struggle with these, don't forget, every Thursday at 11, I have a live help session. So I hope you found this helpful. Maybe you have a superstition you've always wanted to try out. If it is safe and your parents say yes, you could do an actual experiment. Eat an apple a day. Keep the doctor away. Okay, have a great day. That rhymed.